All right, class, we're going to do the VEXVR Disc maze, and we're going to work on loops, for loops, and if then else nested loops. All right, here we go. All right. So the disc maze, we're going to go forward, hit green, turn right, go forward, hit blue, turn left, and we're just going to repeat that until we hit the red right behind me there. And so we're going to set the speed of the robot at 50% power, the drivetrain, and then we're going to go into looks, and we're going to draw a pen. So we're going to draw we're going to trace where we're going, and then we're going to move that pen looking downward. Okay. So we're going to go into controls. We're going to bring in a forever loop, and inside that we're going to build a control or an if then else that's going to recognize first the green, and if it doesn't pick up the green, else it's going to pick up the blue, else it's going to pick up the red. So we nest those inside each other, and so now goes for the commands. Okay, so if we pick up green, what's going to happen? If then, we're going to turn right 90 degrees, and then we're going to pick up that blue. Okay, turn right 90 degrees. There we go. All right, so green's done. Now on to blue. So go to the sensing. We're using sensors in this one, and so if we detect blue, we're going to turn left and drive forward. Turn left. All right, and then we gotta get the red behind me there. So if the sensor picks up the color red, that's the default. We're going to stop, else, and since this is nested inside both the green and blue, we're going to drive forward at all times, no matter what. So if that drive forward was outside of the red, we wouldn't be driving forward. It would stop somewhere. So the fact that that drive forward, the bottom blue code there, is inside all three loops or if then else statements, then it's going to continually drive forward no matter what until it sees red, blue, or green. All right, so that's at 50% power and perfect. Okay, so I think the challenge was touch 5 of the discs, and you're successfully completed this. But let's mess the numbers. We're going to say, okay, we're going to do the turn velocity. Instead of default, we're going to say, okay, we're going to say the default, we're going to put the turn velocity at 50% power. So we can see how that changes things. So the default is probably a little bit slower than 50%, but can we, and that was, I forgot to look at the finish time on that. I think our first run was 32 seconds, I believe. So we're going to change the velocity of the robot and the velocity of the turn. We're going to mess with those for a few minutes here just to see if we get different results on our finish time. So it's doing exactly what we want, and you can see as it is doing the different lines of code, those lines are highlighted in the blocks, and it kind of helps you visualize when you're looking back and forth from the robot to the code what's going on. So 32 seconds on that one, so not much improvement on the from the first run to that run. So we're going to mess with the numbers again. Move the speed up a little bit. Do a fast turn velocity, see what happens. But just to let you know, the slower you do the turn, the more accuracy you're going to get. That does work, and that was 20 seconds. That might be our quickest. So let's see what happens if we increase our speed and our turn velocity. My guess is we're going to make some mistakes. All right, just too quick. The robot can't respond quick enough. So let's slow the turn down, keep the speed at the same. So we're going way slow on the turn. This probably might be a little bit too much still, because that fourth blue disc is just a little bit further to the right, so it's hard for that robot to detect it enough to make that turn correctly. So slowing the turn down helps the robot orient itself to where it's ready for the next turn, or ready for the next drive forward without messing up. Let's see. Okay, so the blues and the greens seem to be fine. Let's see what happens with red. All right, so that's not successful. Everything else was fine, but you cannot be 98% successful with robotics. You have to be 100%, because that 2% it could end up with your robot on the floor. So I'm messing with the numbers one more time. We're going to reduce it way down. Let's see if that works, and let's go three-dimensional. And once again, you can hold down on the control button and the left mouse key to move your visual perspective around the table, and then you can the control key and the roller on your mouse, you can zoom in and out. So let's see what happens when we get to red. So a slow turn, but fast on the drivetrain velocity. So we approach the red a little bit too fast, and yeah, you don't want that. So let's do one more, reduce the speed, and see if we can beat the 20 seconds, I believe, was our record. So you want to make sure you record this down on a sheet of paper so you know which is the best setting. And on the physical robot, you can get the sensor to do different things without actually changing the numbers by positioning the sensor a little further forward on the robot, the physical robot, or just changing the angle that it approaches the object. So that was, I think, 20 seconds, 20.6 seconds, I think, was our record. So you can see how you can adjust, and it all depends on what you want to accomplish out there in the field. If you want to slow down and throw in some code to pick something up, or operate a claw, you may want to slow down for one part of the segment to pick something up. So it all depends on what you want to accomplish. If you want to just time it and race through and get done, Oh, by the way, here is our loops. So we got our for loop on the outside, if then else. Then on the else we got the second if then else, and on the third, which is the red, we got that on the else for the so we got three if then else statements. So you can see on the actual code, here's our loops. The while true at the top there, that is the for loop, and then you got the if and else, three of those, three different colors. And then the top is the drivetrain velocity and the turn velocity, print color, all that up there. So that's robot C. You know, the block code is pretty similar to Arduino, and so if you know one, the logic is going to apply toward robot C and VEX. All right, so I hope you enjoyed this, and I'll see you in the next video.